Hello everyone, this is Poonam Phegde. Welcome to the lecture on finding frequent item set. In this lecture, we will learn the concept of frequent item set and a priori algorithm. Firstly, we will see what is frequent item set and what is the need of finding frequent item set. So frequent item set is the item set that appear frequently in data set. Example, if you analyze 1 week sales data of a retail shop, you may find that milk and bread are frequently purchased together by the customer. So this milk and bread is a frequent item set here. These frequent patterns help in mining association, correlation relationship among data, which in turn help in data classification, clustering and other data mining tasks. So finding these correlations has the commercial significance. For example, if you identified milk and bread is frequently purchased together, this means that a customer who purchased milk likely to purchase bread also. So this co-occurrence information helps in deciding marketing strategies like put some discount on a purchase of bread if both milk and bread are purchased together. So this is an example of market basket analysis. So using frequent item set, we can form the associations rules, and these association rules helps in deciding the business strategies. Now let us see some basic concepts of the related to the frequent item set. Okay, so here in this table, I have put some transactions data on a retail shop. So here bill ID, it is also called as a transaction ID. So it shows the item sets which are purchased in a single bill. Okay, so this bill ID 1 may be of one customer, bill ID 2 may be of the second customer. So second customer has purchased milk, eggs and biscuit. Third customer has purchased chocolate, milk and bread. Okay, so I have put down this data as a relational table here. Okay, so this 1, 2, 3, 4, 5 are the transaction. Okay, and the items which are available in that retail shops are milk, bread, eggs, biscuit, chocolate and tea powder. So this forms the item set for that shop. Okay, and from that item set, customer 1 has purchased milk and bread. Okay, so for now we will see the concept item set. So item set is a set of items. Okay, so for example, milk, bread and biscuit forms the 3 item set. It is called as 3 item set because it includes 3 items: milk, bread and biscuit. The next terminology is support count, or it is also called as frequency, or it is also called as absolute support. So support count is the frequency of item set in a data set, that is number of transactions that contains the item set. For example, support count of item set milk biscuit is 2. Means in 2 transactions you will find milk and biscuit purchased together. Okay, so let us see. So this is the first transaction where milk and biscuit is purchased, and this is the second transaction where milk and biscuit are purchased together. Okay, so this transaction 2 and transaction 4 having the entry for milk and biscuits. Okay, so that's why the support count of this 2 item set is 2. The next terminology is support. It is also called as relative support. It is a fraction of transactions that contain an item set. Example, support of 2 item set which includes the items milk and biscuit is 2 upon 5 equals to 0.4. This means that out of total 5 transactions, 2 transactions include milk and biscuits together. Okay, so this is a relative support. Next terminology is frequent item set. So if the relative support of an item set satisfied a pre-specified minimum support threshold, that is the absolute support of the item set satisfied the corresponding minimum support count threshold, then the item set is frequent item set. Okay, so for example, to which item set you will say it is frequent item set. Okay, the frequent item set means it appears frequently in a transaction, but there should be a minimum threshold value given, and if the frequency of that item set is above to that minimum threshold value, then we can say that it is frequent item set. Next is finding frequent item set. For finding frequent item set, here we are learning a priori algorithm. This algorithm is proposed by R. Agrawal and R. Shrikant in 1994. This is the iterative approach. First, the set of frequent one item set is found by scanning the database or by scanning the all transaction, and then the frequency of each of these one item set is calculated, and only those item sets are collected who satisfied minimum support. So this is the first stage. So in the first stage, you have to identify one item set, such a one item sets which are frequently occurred in a data set and which satisfies the minimum support. Then using this one item set, two item sets are calculated. Okay, so this one item set is then used to find the set of frequent two item sets, and then using this frequent two item set, frequent three item set is calculated. This is continued until no more frequent k item sets can be found. So this is the algorithm for finding the frequent item set. Efficiency of this algorithm can be improved by applying the a priori priority. So what is a priori priority? So if an item set is frequent, then all of its subsets must also be frequent. This a priori priority holds the anti-monotonicity, that is, if a set is infrequent, then all of its supersets will also infrequent. Okay, so when you are forming two item sets, three item sets, four item sets by using the previous, suppose you are identifying the two item sets by using the data of one item sets, you may discard such a item sets which are infrequent. Okay, because the supersets of the infrequent item set is always remain infrequent. This is actually the a priori priority. Now for finding frequent item set, you have to build the item set. So from one item set, two item sets are generated. Using two item sets, three item sets are generated, and this is continued. So here I am showing how this item sets are generated in each of the level. So at the first level, you will find the individual item sets. For example, P is one item, so this is the one item set including item P. Another is Q, then third is R, and fourth is S. So the item set of this data set includes four items P, Q, R, S, and this level shows the one item set. Using this one item set, two item sets can be formed by joining these items. So P and Q will form PQ, PR forms PR, PS form PS. In this way, QR form QR, then QS form QS. Again, R is you will find it in a PR, QR, and RS. Okay, So this is the second level. Then using this 2 item sets, 3 item sets are generated. So this two, when you see these 2 item sets, so this uh, consider this PQ and PR. So using this 2 item sets, when you join it, you will get PQR as a 3 items. Okay, so remember here, when you are generating K plus 1 item set using K item set, there should be K minus 1 common items available in that K item set. Then and only then you can join it to form the K plus 1 item set. Okay, so here in a PQ and PR, P is common. This is a 2 item set, so there should be 1 item that is common. So here P is common, so that's why you can join it to form this 3 item set, that is PQR. Now if you say this, the PR and QS, now nothing is common there, so that's why you cannot join it. Okay, but again this PS, QS, so S is common, so we can form the 3 item set as PQS. So in this way, using this 3 item set, you can generate the 4 items. Now what is a priori principle? As we have seen in a previous slide, that a priori property holds the anti-monotonicity. If a set is infrequent, then all of its supersets will be infrequent. Okay, so it can be used to reduce the search space while you are finding the frequent item set. So how? So let us see. Now we have seen how to find the frequent item sets, how to create the level wise item sets from 1 item set to 2 item set, from 2 item set to 3 item set. You reduce this search space by applying the a priori priority. For example, at the second level, you will identify that RS is infrequent. If you find the frequency of RS in a data set and you find that it is below to the threshold frequency, then it is infrequent item set. Okay, so all the supersets of this infrequent item sets also remain infrequent. Okay, so the superset of RS are PRS, QRS. Okay, and using this PRS, QRS, you can generate a PQRS. Okay, so all these becomes infrequent. So if RS is infrequent, all these 4 becomes infrequent. So no need to generate PRS and QRS when you are forming 3 item sets using the 2 item sets. You can skip formation of this. So in this way you can reduce the search space. Okay, and this is called pruning. Okay, so this is called a prune superset. So what is actually a priori algorithm and how it works? Let the K is equals to 1. So generate the frequent item sets of length 1. So this is the first step, that you have to generate a frequent item sets of length. After that you have to repeat following step until no new frequent item sets are identified. So using this 1 item set, generate length K plus 1 candidate item sets. Then prune candidate item sets containing subsets of length K that are infrequent. Okay, so you have to prune the candidate item sets whose subset are infrequent. Then count the support of each candidate by scanning the data set. Remove candidates that are infrequent, leaving only those that are frequent. Let us see this with one example. So here I have noted the transactional data of a retail shop. Okay, so total 5 transactions I have considered. So customer 1 has purchased milk bread, customer 2 has purchased milk, eggs and biscuits, like that. Okay, now from this data sets, we are now finding the frequent item sets. Okay, so the first step is you have to find the frequent 1 item set. So for finding frequent 1 item set, you have to consider the individual item in that set. So milk, bread, if you find milk, bread, eggs, biscuit, chocolate and tea powder, these are the items, so they forms the one item set. After that you have to calculate the support count of each. So you will find milk at 5 places here, so all the transactions includes the milk, so that's why support count of milk is 5. In this way you have to calculate support count of rest of the items. Okay, now here we are assuming that minimum support threshold is, and it is support count, and it is equals to 2. Okay, so from this one item set you have to calculate the frequent one item set, and frequent one item sets are the item sets whose support count are greater than this minimum support count. So minimum support count is 2, and this tea powder item set has support count as 1, which is below to the minimum support count, so that's why we are not going to consider this. So the frequent one item sets includes milk, bread, eggs, biscuit, chocolate. These item sets are used to form two item sets. So for forming these two item sets, we will combine this one item sets with itself. We will join this one item sets with frequent one item set with itself. So milk will join with the bread. So milk, bread, you will get another entry at milk, eggs, milk, biscuit and milk, chocolate. Then bread, eggs, bread, biscuit and bread, chocolate. In this way you will find the two item sets. After that, find the support count of these two item set by scanning your data set. So you will find milk and bread on 3 transactions, in a 3 transactions. So you will get milk, bread here 1, then 2, and this is 3. Okay, so in this way we have to calculate the support count for all these two item sets. Okay, then remove the item set whose support count is below to the minimum threshold value. So we will identify the item sets like bread, eggs, bread, biscuit, bread, chocolate and biscuit, chocolate, which are having support count which is lesser than the minimum threshold. So we are not going to consider this item sets in a frequent two item set. So frequent two item sets only includes milk, bread, milk, eggs, milk, biscuit, milk, chocolate, eggs, biscuit and eggs, chocolate. Here we are not applying, there no need to apply the pruning stage, because all the subset of these two item sets, that is individual, if you say milk, it is a frequent because it is greater than the minimum threshold. Bread, eggs, biscuits, all these are greater than the minimum threshold. Okay, so this is the frequent two item set. Using this frequent two item sets, we can generate the 3 item sets. So now if you see all the combinations of this, so milk, bread can be joined with the milk, eggs, okay, because milk is common, so it will give the entry milk, bread, eggs. There's the another entry may be milk, bread, biscuit. If you join this row with this, then it will give milk, bread, biscuit. Then milk, bread will be joined with milk, chocolate, so it will give milk, bread, chocolate. But now here, when we are creating the 3 item sets, we have to apply the a priori priority. So we are not going to consider the 3 item set whose subsets are infrequent. Okay, so now consider the formation of the 3 item set using this 2 item set, milk, bread and milk, eggs. So the 3 item set is milk, bread, eggs. Okay, so this milk, bread, eggs has this subset as bread, eggs. Okay, so this is a 2 item set, bread, eggs. So you will find it here. So bread, eggs has a support count 1, which is lesser than the minimum threshold value. Okay, so that's why we cannot consider this superset of this bread eggs as a milk bread eggs, because the if this set is infrequent, then its superset is also infrequent. This is the a priori priority. Okay, so we can prune out such a 3 item sets whose subsets are infrequent. Okay, so such a 3 item sets are listed over here. All these are pruned out. Okay, so only 3 item sets which are considered here are milk, eggs, biscuit and milk, eggs, chocolate. Okay, because if you check the subsets of these 3 item sets, they are frequent. Okay, so let us see the subsets of this 3 item set. So milk, eggs. Okay, so if you check here milk, eggs, so its support count is 3, means it is above the threshold value. Then another subset is eggs, biscuit. So if you see eggs, biscuit here, okay, support count is 2, which is equals to the minimum support, so it is allowed it. Milk, biscuit, its support count is 2. So all the subset of these 3 item sets are frequent, so we can consider these 3 item set. In this way we will find only these 3 item sets. Okay, then after calculating these 3 item sets, you have to calculate the support count of this. So you have to find out how many transactions include this milk, eggs and biscuits together in a transaction. So it is 2 times, and also milk, eggs and chocolate, it appears 2 times. Okay, now if you try to form the 4 item set using this 3 item set, then 2 items from this 3 item set must be common. So if you try to join these 2 entries, then there should be the 2 items common. So milk, eggs and milk, eggs, these 2 items are common here. And if you form the 4 item set like milk, eggs, biscuit, chocolate, okay, but when you apply the a priori priority, okay, the subset of this milk, eggs, biscuit, chocolate, which is biscuit, chocolate, it is infrequent. Biscuit, chocolate is infrequent here, so that's why you cannot form the 4 item set using this 3 item set. You have to stop here. So from these data sets you will get 2 frequent item sets, and that are milk, eggs, biscuit and milk, eggs, chocolate. Okay, so this means that the customer has frequently purchased milk, eggs and biscuit, and also milk, eggs and chocolate together. Thank you.